Hey guys, so we are doing another STAAR warm up. This kind of goes with what we were learning about yesterday, and you're about to see how. So this says, a bag contains 5 red, 6 blue, 3 green, 4 black, and 2 yellow marbles. A marble will be drawn from the bag and replaced 100 times. So they take one, they put it back, take one, put it back 100 times. What is a reasonable prediction for the number of times a green or black marble will be drawn? So again, we're making a prediction on this one. So if you remember, I told you if you have a prediction, you can pretty much guarantee you're going to be doing a proportion. So we put our total on bottom. We want green or black. So remember I told y'all, think of this as like you're winning. You're winning if you get a green or black. Okay? I'm going to put BK. Now, this is my sample over here. Right here is my sample. So my sample, I need my total. 5 plus 6, 11, plus 3 is 14. Plus 4 is 18, plus 2 is 20. And then how many are green or black? Green and black. When you add those together, what do we get? I underlined the wrong one. I said blue. I'm like, that's not correct. Let's try again. Green or black? 3 and 4. Okay, and again, this goes back with checking your work. 7, okay, so we have 7. Now, we don't want to know for 20, we want to know for 100, if we did this 100 times. So basically, when I look at this, it is saying I'm going to get black or green 7 times if I draw 20 times. This is kind of like theoretical. Theoretically, that's what I should get. So now, I want to solve for x, okay? How many out of 100? So your job is A, to cross multiply that, or B, find a relationship and choose your answer, okay? Now the next one, number 5, says Leticia has 2 bows of flowers. Each bouquet contains 13 daisies, okay? Bouquet S contains 30 flowers, and bouquet T contains 13 flowers, okay? Each of these contain 13 daisies. I read that to myself twice, okay? Which statement is true, okay? So I want you to think for a second as we move through here. Before I even start reading, look, probability, 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 probability. This is going to obviously have to do with some kind of probability problem, right? So what I want us to figure out is, notice daisy, 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 daisy. What I would do is, even again before reading these, is I'm going to say, okay, for bouquet S, we know there are 13 daisies out of 30. Okay, 13 are daisies out of 30. On bouquet T, it's 13 are daisies out of 13 flowers. Here's the total, right? This is total, this is total, this is daisies. So guys, this means 100% of the flowers are daisies. Okay, I can't spell. Okay, so letter A says the probability of randomly selecting a daisy from bouquet S is less than the probability of randomly selecting a daisy from bouquet T. Okay, guys, that is true. This is not 100%. This is a 100% chance when you reach in here. You have a 100% chance of getting a daisy. So I already know that this is true. Okay. Letter B says the probability of randomly selecting a daisy from bouquet S is 1. 13 over 30. That doesn't equal 1. 13 out of 13 equals 1. This one equals 1. This one is false. Letter C, the probability of randomly selecting a daisy from bouquet S is equal to the probability of selecting a daisy from bouquet T. So even though there's 13 daisies from each, guys, the probability is not the same. Okay, I hope you see that. If I reach in this one, yeah, I have a pretty decent chance of getting a daisy, but I have a 100% chance here. Okay, and D, the probability of randomly selecting a daisy from bouquet S is 1/3. This does not equal 1/3. I can tell you this because it's not going to simplify down to 1/3. I cannot simplify this any further. This is prime and not a factor of 30. 10 out of 30 would be 1/3. Okay, so this one is incorrect. And even if you don't know this one, we can factually say letter A is correct.